We are not going to be, I'm not going to be holding you for 2 hours. I'm just going to give a very short intro to what this is all about and what's important and what's not. And then hopefully we could have a very brief discussion, go around to see where you are at in terms of topic area, in terms of supervisors. And that's the most important part. So the advanced project work, as you can see from the official course description, it's a small project where the aim of the project is that after completing the course, you should have thorough knowledge of professional scientific theory and methodology in the chosen field, so that you will be capable of conducting an R&D project in the area. And you have obtained practical experience in conducting such a project and in documenting the results in a scientific manner, and a positive attitude towards working in an academic and problem-focused manner. What does it mean? Well, it means, if you look at the project you'll be having, so in the applied computer science project, you were introduced to tools and methodologies. In the integration project, you were using state-of-the-art, ideally state-of-the-art APIs and technologies to develop some advanced features, but that was still just development work. And global software development is development work. Now in this project, we put in the R there. So it means that it's going to be more on asking and answering questions than developing. So you may still develop, but the purpose of developing is to understand the phenomenon, to learn something more that we didn't learn without doing the development work. So here what you should be able to is to use your skill in the area, and that's why it says on the basis of these advanced courses. So it should be at the very edge of your field in terms of what we know, what we don't know, what has been done. You may want to run an algorithm or different types of data. You may want to compare two algorithms. You may want to use some technologies. You may want to choose between two alternative technologies in solving a problem, not knowing which one is better. So and it's 5 credits, so it can be very big. It needs to be something that is reasonably small, and it's a project that you need to set up some research question to be answered, and you will answer through whatever you develop or study. So since it's research and development, it doesn't have to be a very strong D. It can be more towards research. It can be more towards development, but it still needs a bit of both parts there. And of course, scientific methodology. It's kind of the foundation for doing literature reviews, having academic work, having a methodology, and being able to assess and kind of criticize or look at the methodology, whether that was a good one for the purpose. The reason why we have this course is that the master thesis is a much larger project of this type. So if you look at the courses you've been having the advanced courses to get into an area. So you know the research, you know some of the problems, you know hopefully where the state of the art is. And we have the research project planning course, so that you can plan for a project, plan for a large project, knowing what the problems are, knowing what other people have been doing in the field, choosing a proper methodology, and putting down some milestones and plan for what you want to do. And then this project, what we learned in the beginning, we didn't have this kind of project, is that the research project plans were too ambitious. Students were thinking, oh, we can do all this in 6 months. And what we hope is with this project is to get to see that you can't do too much. I mean, there's a lot of work involved in setting up and finding data, getting data, analyzing data, reporting. So we would like to know that you have the experience from this in small scale as you plan and work on your project plan. So the two courses, research project planning and the advanced project work, are independent, and they are kind of independent of the master thesis. There's nothing in the master thesis saying that you need to base it on your advanced project, or that you need to base it on the research project planning plan. But what we hope is that through the research project planning, you know what it takes to plan a good project. So if you decide to change a topic, then you should do a mini research project planning to make sure that your new topic is based on a good plan or a good analysis before you start. And with the advanced project work, the most important part is that you really get to do this kind of project and understand what it takes, and whether you use it or not directly in the master thesis, that's not so important. It might be useful because then you can step one step up because you have done a part already, which is outside of the scope of the master thesis, but would lead you into the master thesis. So it would be good. And then the question is, how are we going to do this? And it says here that the topic, you should choose it with a supervisor. Who hasn't decided who the supervisor is going to be? Any of you who still hasn't decided? You all know who's going to...
Was it research project planning or?
Advanced project work for this project. Sorry, you don't know yet. So that's number one. Because, I mean, the topic, you should agree with the supervisor on the topic. So pretty quickly, because I mean, time is running, and you don't have that many months or weeks even to do the project, and you need to plan it, set it up, run it, and then write up a report. So there are some activities involved. So I suggest that you do that pretty quickly. But also, if you look at the teaching methods, it says project work and tutoring, which means that it's being supervised. So your supervisors are there to help you to get this type of outcome. But the supervisors won't change you. So if you aren't asking for meetings, they won't come and bother you mostly. Which is, we see that happening. It's unfortunate that I think most students should be seeing the supervisors more often than what they decide to do. Because I mean, I think you learn more by working closely with the supervisor. You get feedback from the supervisor as you move on and get hints. Now, remember, it's your project. So, and if you look at the grades A and B, it says something about level of independence. And so if you do exactly what the supervisor tells you, then it's probably going to be a C at the best. So it's a little bit, what the supervisor says is input to you to consider, and you need to process it further to say what that means to you. Should you follow it? Should you make a little bit adjustment to it? Should you do something different? That's up to you to decide. Should you do something more? In the end, you will submit a project report, and that's the only thing that will be assessed. There won't be an oral exam, there won't be any reflection notes, nothing. It's just the project report as such. So the project report would typically be like one of the scientific papers you have been reading. So we describe what were your research questions, what other researchers been doing in the field, how did you set it up, what did you see, what did you experience, how do you interpret that, what can you conclude from that. That's the like we see in the most research papers. So that's kind of the structure of that report. It's going to be close to a technical or scientific report, and it's graded A to F as most of the courses. Any questions? Anything I forgot to mention? Any concerns? So, as I said, the number one thing to do if you don't know exactly what you want to study is you don't have a supervisor, is to start with a supervisor and nailing down a certain project. And from experience, I would say that if you can come up with projects that are too small and easy or too complex and ambitious, and I think most students tend to be too ambitious and think that they can do a lot. So I think I was saying this before, that estimation is hard. And estimation requires that you know how much work it is and how efficient you are. And in this case, you don't know either of them. So it's hard to come up with a good estimate. So your best effort is probably off quite a lot. So typically we multiply a factor 2.5 or 3 with the initial estimate. Now your time budget is fixed here, so which means that you can only do about the third of the work that you think you will be able to do in the same time frame. So that's the way to think here, is that if you have something, cut it in 3 and do 1/3 of it. That would typically be a good strategy. Because, and this applies to the master thesis as well. So we'll talk about this next time we meet in the research project planning core, is that it's easier to start with something that's on the small side and scale it up, because typically when you work on something, you find more interesting stuff that you can explore around the small thing that you've been studying. If you start with something that's too big, you start working on it, and midway you realize that it's too big, and if you cut, it's hard because you've been doing a little bit here and there and there. So whatever you cut, either you cut off something that you have already spent time on, or you need to keep it all, which means that parts are not going to be as well developed as other parts. So in either case, it's better to start small. And I mean, if you see that it's really was too small, then extend it. Okay.
The question is, if you say you should all start small and then see how much you can develop from it. The idea is how relevant then that would be for the research community. So how much would you contribute for just taking a small task?
Small doesn't mean that the answer is known. So it's all about the answer, whether the answer is known. And what you have to think of here is that we make small steps. So it's not like we make huge leaps in terms of, or from a 5-credit course. These are small steps. So it's not like we expect you to make big contributions to the community. What we ask you for is for a project in which we don't know, we can say already that we know what the answer is going to be. And how much that contributes. I mean, it's 5 credits, you aren't even at the master's level yet, so we don't expect it to be that strong of a contribution. But it's a concern. So there are two aspects here. One is the size, and one is the challenge. So challenge will still be high. I mean, the ambition and challenge, but the size of the project may not be too big. So for instance, last year a couple of students do projects on the triangle, Google Triangle? Have the Tango, sorry, where they have the 3D or the sensors for measuring distance. And they had a couple of projects. They were trying to come up with ideas and how you could use that for indoor navigation. That's a pretty big application because you need to look at the calibration, you need to look at route finding, you need to look at the accuracy. So there are many topics that are quite challenging themselves. So rather than saying, okay, I'm just going to worry about the accuracy in this scene, and if that's easy to do, I'm going to extend it to more complex scenes. Or saying, okay, I just assume that I have these data of certain quality, and then I'm going to look at the path finding when obstacles have been changed or moved. So they might still be ambitious, but not trying to cover the whole from sensor to final application and end user testing. That is kind of too ambitious. And there are the feedback they got from the examiners where it was so thin spread, so you couldn't see the contribution because they touched on so many topics. If they've chosen one topic, contribution would be much better, even though it was just a tiny part. So if you find some new devices or some new algorithms, don't necessarily think of having a complete system, develop a complete system. Look more at one part of that system and assume that the other parts are there, and then you could study this part in more depth and understand what it should and should not do, what it could not do. So it is challenging because it's very hard to specify upfront what is the correct size, what is the correct complexity or challenge level, because if it's if it turns out it was just straightforward development work, then obviously the challenge level wasn't so that it could give you the best grades, because you could prove that you really were able of conducting the project, because there wasn't so much R in it. It was more D than R, so you can prove the R part. When it comes to the types of projects, it's really widespread here. What is typical is to do kind of, or what may be very useful is to do kind of feasibility, a small feasibility. So if you're thinking of testing out some algorithm, let's say one year we had a student trying to use the mobile phone for detecting falls. See if you could, if a person had fallen compared to just walking or sitting down or some normal activities. And for that, did a small study with just very few people and separating between very obvious falls and walking, just to see what type of data we will have. And that was a small study, so we couldn't come up with any conclusive data or recommendations, but at least got to understand what were the challenges, and then what would be, how should we set up a larger study, and what will be important, what are the additional scenarios that should be tested. And also, one year we also had a student who would like to implement a simulation on the web app, and wondering whether you should use vector graphics or canvas, and then you can specify what would the features of the simulation, and then try to compare, look at the canvas-based versus the graphics, vector graphics-based, and see which ones seem to be performing better and also easier to program. Any questions or things that come to your mind? What stops you from spending 5 hours on the project tomorrow? If there's anything stopping you, then that's what you need to.
Not sure where to begin.
Where to begin?
Yeah.
So you haven't chosen a kind of research problem or problem?
Yeah, well, in the project planning,
yeah,
but not sure what this can contribute to that.
Well, yeah, I see that urge to connect them, but what's more important here is to at least run a project, because I mean the grade here is independent from whether it contributes or not. So the important thing is to get into and run and get some hands-on experience from doing a small project. And it's it's like this is red. So you have the problem description, and you probably have a problem description, and then from problem description you come up with some initial research questions, and the research questions, they will help you do literature review, find related work. Sorry, and from the related work, you will typically find that the research question isn't clear enough, or it's being answered already, or it seems to be too ambitious. So then you revise the research questions. At some point, you have research questions that you can base your plan on. And here, you can pick one of them, or you can say, okay, this is too big, but I can take a part of it. So once you have research questions, it should be possible to take parts of it and say this is an advanced project work question that can be answered in this program. So that would be one way. So depending on how far you come in going from product description to project plan, you will may not have a research question. And sometimes, as I said, sometimes the advanced project work will be more on what tools you should use for these, or there may be that you need a certain algorithm that is, or need to choose an algorithm. You don't know which one, but that's not the focus of this work. But you need to have one in place before you start. Then this might be a good candidate for that kind of work. And as I said, if you haven't been in touch with the supervisor, this is a good time to do so, to say, okay, now, given that this is what I want to study, what could we do for a small project in advanced project work. I would think that typically advanced project work projects would not be too much end user. I mean, you wouldn't be having too many users involved in doing user tests, because this is kind of more preliminary studies. Because it would be hard for you to set up a project, get all the users, develop what you need to test, and have it tested and have it reported in 5 credits and a half or half of a semester. So it's not even half, I guess. You're passing it all the semester.
So do we have to schedule a meeting with who you potentially want to have a supervisor?
Yes. Yes. That's what we need to do. And it's also, you will also, these are your projects. Same with the master thesis. These are your project. Your project manager. The project manager needs to be driving the project and make sure that it gets the input from supervisor and from others when needed. Yeah. Anyone having ideas? They wonder whether they are good ideas or what? Again, what? So you didn't even know. That's pretty much, I guess, for everyone. You don't know where to start. Is that the problem? You don't know where to start. How far have you come in terms of identifying research questions for your master thesis or research project planning project? And again, if you see already that this is not what you're going to continue doing, it might be that you already started on something on the research project planning and you see this is not what I want to do. Rather than swapping a topic now, it may be that you decide to continue, then you need to find something else that you like to do in a small project.
Maybe you can say if it's a good idea for advanced project work. I'm thinking now to try to, on my master potential topic, could be investigate game companion for games for health. That's gonna. There is hospital that make games for health for children, and they experiment with a robot sitting next to a computer when child plays and how it kind of works. So I could investigate how this game companion could work if it would react on what happened in the game, like if child succeeds, for example, it has some feedback to child, and also the doctor and parents can also control this robot. So for advanced project work, maybe part could be because one thing is that when if I will develop a library that game developers can include these controls in their games, but also there is challenge with already existing games. So what I could do is I could use image processing from the game and provide with simple framework to say that, for example, this part of the screen should be scored, and try to detect what score is, and if it's above 1,000, like play some sound or something like that. So I will have to use image processing of the game play and try to extract some features, like, for example, recognize text, recognize color, and provide you with these kind of triggers and actions that robot can do. So as advanced project work, I could see how to make this recognition, for example, on the image recognition part of the games, how to extract these different features like average color, current score, for example, or something like that. Is it something suitable?
Yeah, I think I need to frame it a bit better, but it obviously could. I mean, you could have more environmental issues like background, light, and position. Or, I mean, there are lots of topics that eventually, because I mean, it would be important in your setup, assuming that this is all based on the image input, so you don't have direct access to the program, so that you get data from the program.
Well, I could potentially just take video stream from the future.
Yeah, that you could absolutely. And then that would be easy to process. And then there's a question of whether you would like to test it on many games, because one thing you could do is look at a different game to see how this data is being expressed and how easy it would be to specify where to pick it up and something like that. Yeah, because I mean it would be something that you would need in that kind of system to be able to recognize. So you could look at what are the events, what are the important events, what are the events that have visual cues, how are the visual cues being, and try to set up a kind of a matrix of areas, so that you see how easy each one will be to detect.
Yeah. So to see how much I can detect, how easy it can be detected.
Typically, we're interested in performance. The performance would be how many you misclassify one way or the other. The things you detected weren't really events, and the events you didn't detect. So that you should have those are errors in both sides that you know. That's typically what we will do in such a study. We will look at that performance.
Mm-hmm. And in this report, we should make literature study as well, or it's not.
Well, it says that after completing course, students have gained thorough knowledge of professional scientific theory and methodology. So you are supposed to be having a decent state-of-the-art partner, and that's the advantage of doing this at on the same topic that you are doing in research prototype, because there you will look at it in more detail. So you could kind of share and use part of that study, the part that is relevant. But yeah, you can't do research work without knowing where the state-of-the-art is. So that's always there. So there are, as I said, there are different types of projects. So if you look at the scientific methodology and look at different methodologies and types of projects, there are many types of projects. The ones that are easier to manage with those that are kind of small and towards being experimental. So you set up something small scale and you test lots of parameters and you analyze the response based on the parameters and then conclude something about that smaller experiment, even if it's not necessarily a real experiment, but it's kind of that type of project, because it's easier to draw the boundaries, to define it, and it might be easier to frame research questions, and then you don't have too much of vagueness, because vagueness is a problem here. If it's unclear what you want to study, unclear what you want to find, then it's definitely sure that you don't contribute much. So the more accurate you are, and I can say that as well when it comes to research project planning, the examiners I've been using before to review, that's really what they put the most weight on, is whether the research questions seem to be solvable, seem to be reasonably well defined, so that it's easy to understand what it involves and whether you understand how much work it will be and whether it can be done. Because many times you have relevant research questions, but it doesn't seem that the student would have the knowledge or the time or the other resources to answer it or answer the questions. So it's important here that you try to find something that is reasonably accurately defined, so that you can actually work on it. But there will be, that's also, so you think about a project. So you have your research question, and then you set up your experiment or your study. I mean, in the web case, the setup would be what are the journals you search in a web tech course, what are the journals you search, what are the keywords you look for, So that kind of setup. And then you have results, and based on the results, you do analysis or a discussion, and then you conclude. So the conclusion is based on analysis, it's based on the results, it's based on the setup, and supposedly for answering research questions. So when you read papers, it seems that they all had the research questions clear in mind when they set it up, and then they get the results, and they analyze and got the conclusion. But that's usually not what happens. So usually you have a big idea, and you start setting up, and you get some results, you find, that I can use that for March. So then you go back to the questions, and you go a little bit back and forth here. And in the end, you know what research questions you answered, you know which setup you ended up having, and then you know the results and the analysis. And then you write it as nothing else that happens. So it seems like this was planned all the way, but it really is. So that's why I'm saying reasonably accurate, reasonably constrained, because if this is too vague, you can't really start getting into these loops. So you need something that is clear enough, but usually we don't know the exact question until we have been going a few times through this loop here, unfortunately. Unfortunately, this course, especially because we have all the half the semester, so it doesn't give much time to do many rounds of iteration. More confused than relieved? Maybe, maybe not. So this would typically be the type of this would be kind of the general outline for the report. So we have introduction, describing the problem, describing the area, the relevance, why this is useful, and something that is worth studying. And then you say, okay, these are the exact questions. When I answer these questions, we have a small improvement in the community and in the field. Then you describe what you did, how you set it up, what you did, how we got data, and separate. Then you present the results, and the results have been discussed with the purpose of concluding in respect to these research questions. So this is kind of the scientific paper structure. IMRAD, isn't it? Introduction, methodology, results, analysis, discussion. Yeah, analysis and discussion. More like called this separate rather methodology. So what is your next step? You all have an idea what next step is, or who does not know at all what you're going to do next?
Who doesn't know?
Yeah, but you don't know what to do next.
Because I chose for the research project planning the anomaly detection in healthcare, but then I talked with Simon and Mariusz, and they said that it's hard to get data from healthcare. And so then I'm just reading now a book from a PhD student that Mariusz gave it to me, and it's related with fraud detection in banking. So I'm just going through that, and I'm maybe trying to get something.
Might not be easy to get data there either. Banks don't go to give you too much.
So I have no idea.
Did you talk to Catherine at all?
No, I haven't.
Yeah, because she may have some other kind of fraud detection projects in which they do have data already. So it might be that because she's into that field. Yeah, no, I mean, if you are not knowing what area to approach, what problem, then that's what you need to do. You need to work hard on the problem description. So it depends on how far you are into this to see what you should do. I think that the most important part of getting progress is to start doing something. It's not so important what, as long as you start doing it. Because here, this way, it doesn't matter whether you start on the literature or the research questions or try to understand the problem, because eventually they interact, they all play together. But you need to start. To cut that circle, you need to start somewhere and get into it. So it's not so important where you go, it's just that you start going. And then eventually the road is going to make itself appear, I guess. And I don't know if you can say much about the grading, because the grading is it's based on this. So it will be a question of whether this is really kind of at the forefront in the field. It's a question of whether you demonstrate R&D capabilities. You are able to find new knowledge. You are able to assess whether this is solid or not. And usually, I mean, it's not per se a problem to say that you have just weak indications, you don't have strong evidence, because this is a small project. What's important is that you can claim more than what your project can support. That's important. So and the examiners would know that this is 16 credits, half a semester course, so the expectations are within that frame. But it's also important that when you present, that you clearly show that you understand the limitations of your work, the limitations of the contribution. Besides that, it's about the how well you set it up, how well you analyze. So I think there's something the master says about this as well, that the conclusions need to be based on your analysis. The analysis needs to be coming out of the result. The results is based on the set that you have. So, and they should all answer your research questions. So it's more much about the craft of putting this all together. So it's not just whether this was an ambitious, exciting project or not. It's also about how we went forward to solve it. Which means, and I don't know if I said this before, maybe to some of you. Usually, when we talk about the research, usually a lot of people would think of this as the important thing. I mean, research, you need to have some questions, you need to run a study and get some results. But the research is really about this part. Given that you have results, how can you interpret them? What can you learn from them? So I often see reports that are quite detailed in this part, and then when it comes to discussion and conclusion, it's half a page and a paragraph, which is unfortunate, because here is where you really try to understand the results and try to interpret them in different ways and try to discuss alternative interpretations and discuss relationships. So this is the most important part: discussion, analysis, discussion, and conclusion. And also, in the setup and results, it's important that you discuss why you chose to do it that way and not other ways that might have been chosen. So if you did test something and it didn't work, then write it up, that this was one alternative that you tried, it didn't work, and the reasons why it didn't work. So it's not just saying what you did, but also what you learned through this whole process. What you learned when you set it up, what were you thinking behind choosing that perspective rather than other perspectives. And that's interesting as well.
The real long conclusion shouldn't be very long. It should be kind of short and precise what you found.
Yeah.
I can see that the discussion should be kind of long and cover a lot of aspects, but not that too.
It's a difference between just saying we found the users were happy and writing several pages. Yeah, no, absolutely. It's shorter, but it should still pull together the pieces, and usually it's more than just a paragraph, which is more. But it's my thing is that definitely it's most of the analysis part, because that's what leads up to the conclusion. But the weight between describing what you did and what you learned from it. You need to know more, you need to see more of the text describing what you learned, why you did, why you did not, and not what you did.
Are we going to have lectures?
No.
Seminars?
No. Just you, because you all have different topics. And your methodology-wise, you had scientific methodologies, you know that, and you had the advanced projects. You should know your fields. So right now, the only thing to do is to work, and that's why we have the tutoring with our supervisors that will help you and give you feedback individually. We did talk about reflection, so this is probably where you are. So after you do something, you need to reflect on what did we experience, and then we need to say, so what? What did we learn from that? What was the explanation? And then we say, now what? Meaning, what will we do different next time? In what way should this change us or the field? And then we continue to do something, and we start reflecting. So this is kind of the cycle that we're going to go through. And if you just describe what you did without thinking about what does this mean and how should this influence us, if you don't discuss that part, then there isn't much to learn. Maybe I should have done this and put on the camera instead. Sorry, I should have had this already, so you could see what I was putting the board. But okay, it's not perfect.
So you feel ready to get started? Almost. Yeah. It is a hard. It's hard, and as you say, the hardest part is not knowing what to do, because then you can't really progress much. So my suggestion would be that if you don't really know your problem area yet, then that's the first thing to really grab something and get going there. If you are here already have some crude ideas about the project, then it's just about taking one of these research questions and strip them down and get something defined that you can start working on. Okay, if you don't have any further questions, I think it's time for you to talk to your supervisors and start making a plan. Okay, Lord? Yes? Yes, it's okay. Good.